Okay, in this video here, we're going to take a look at algebra sections 2.1 to 2.3. Again, we're going to combine sections as we go through the first few chapters just to save us some time down the road for some different activities and different things so we can go into a little bit more detail with certain concepts. So, first of all, classifying numbers. You'll notice you have a big table right on the front there that's going to kind of give you the just a rundown of all the different types of numbers we're going to study. Okay, so the first type of number we're going to look at are called whole numbers, and these whole numbers are starting with 0 and then all the positive numbers. Okay, so 0, 1, 2, 3, 4, 5. So what kinds of numbers are not in this set? I think it's pretty clear that we don't have any decimals, and we do not have any fractions. Okay, so decimals, fractions, negative numbers, none of those are in whole numbers. Whole numbers are very simply 0 and then all the counting numbers, 1, 2, 3, 4, 5, so on and so forth, all the way up. Now, integers builds off of whole numbers. Okay, so whole numbers is kind of the most specific small set of numbers that we can talk about. Okay, as we get into this idea of integers, now integers is all the whole numbers plus the opposites of the counting numbers. So all of the negative, negative 1, negative 2, negative 3, negative 4, negative 5, so on and so forth, and then the positive 1, 2, 3, 4, 5, so on and so forth. Okay, the numbers that are not in this set are still, we don't have fractions included in this set, okay, or decimals. So decimals are not included in this set. And then finally, we get to the most general type of number that we're going to talk about. Every number we're going to talk about in this class is a real number. Okay, all real numbers can be placed on a number line. They include whole numbers, integers, and two more types of real numbers. We first have real rational numbers, which are decimals that end, or fractions where the numerator and denominator are both integers. So, for example, 3/4 is a real rational number. It's rational because you can write it as 3 over 4, and when you look at the decimal, it's 0.75. That decimal ends, or if there's a pattern to the decimal. So, for example, 2/3 is the decimal 0.66666 repeating, and so since there's a pattern there, that would be considered a real rational number. Okay, irrational numbers are really the best thing to explain it. They're decimals that do not end and there's no pattern to them. So pi is a good example, and then the square root of any number that is not a perfect square. Okay, so as we go through and look at these numbers, they can be more than one. All right, for instance, negative 23, that is an integer, and it's also a real number. Okay, if we're being more specific, it's a real rational number. Okay, and really you should probably work the other way. You should ask yourself, okay, we know it's a real number. All of these are real numbers. Okay, this is a real number. And it's rational because the decimal point ends. This is a real rational. This is not a real rational. It's a real irrational because it's the square root of 17, which is not a perfect square. This is a real rational. It's already written in fraction form. And then part F here, I'm not going to be able to zoom in. I think it's square root 25, and so clearly that is a real rational number. Okay, and then you go through and ask yourself, okay, once you're a real number, now are you an integer? Okay. No, yes, so this guy's an integer, no, no, and the other guy's really, this is just 5, and so yes, that is an integer as well. And then finally, are you a whole number? Okay, this guy is a whole number because it's positive, and so is 5. Okay, so all of them are real. Some of them might be integers and might be whole numbers. Okay, and that's kind of the way to think about it. Always work your way in that order. Okay, you are real. Okay, now once I've established that you are a real number, are you an integer? And then if you are an integer, ask yourself if it is also a whole number. Alright, so again, these should be ideas that you're familiar with. Hopefully a refresher here will do us some good. So it says which number is a whole number. So you start looking at it. We haven't gotten really into this discussion quite yet, but this here, these little vertical lines here mean the absolute value. So you have the absolute value of negative 2, which is positive 2. And so choice A is your whole number because 2 is a whole number, right? It's 0 in all the counting numbers. Okay, two ideas here: finding the opposite of a number and then finding the absolute value. The opposite of the number are two numbers that are the same distance away from 0 on a number line, but are on opposite sides. Okay, so for instance, if I say what's the opposite of 4, I think every single one of you could tell me -4. Okay, if you look on a number line now, okay, here's 0. Well, -4 is going to be 4 this way, and +4 would be 4 this way, and so they are the same distance from 0 on the number line, but they're going in opposite directions. So that's kind of what it means to be an opposite. Okay, and then the absolute value of a number is the distance between 0 and that number on a number line. Okay, so for instance, if you look up here back at my number line I have here, the distance from 0 to -4, sorry about that, the distance from 0 to -4 is just going to be 4 units, right? 1, 2, 3, 4. Okay, the distance from 0 to +4 is 1, 2, 3, 4 more. Okay, so the distance from 0 to -4 is 4, and the distance from 0 to +4 is also 4. So you'll notice, if you remember, the absolute value can never be negative, because again, the absolute value represents the distance. Distance can't ever be negative. You can't ever travel -7 miles. Okay, you can travel 7 miles in the opposite direction, but that's still not -7 miles. All right, so example 2 says find the opposite and the absolute value for each number. Okay, well, the opposite of 3/8 is -3/8, and the absolute value of 3/8 is just going to be 3/8 itself. So if the number is already positive, the absolute value is going to be the same thing. If it's negative, you just make it positive. Okay, so let's see here. The opposite of -0.65 is positive 0.65, and the absolute value is going to also be 0.65. Okay, opposite is positive 4/7. Absolute value is positive 4/7. Opposite -5.3. Absolute value positive 5.3. And finally, really, this guy is the opposite of -9, so this really just means 9. Okay, so the opposite is -9, and the absolute value is positive 9. All right. So again, absolute value always positive. Opposite just means if it's a positive number, the opposite is negative. If it's negative, it's positive, etc. Okay. It says add and subtract real numbers. Okay, and know how to use the properties. So when we look at the rules for adding and subtracting positive and negative numbers, remember, if you're subtracting a negative, it's the same thing as adding. Okay. And if you're adding a negative, it's the same thing as subtracting. So for instance, I could think of part A as 2.7 plus -5.2, or if I wanted to rewrite that, if I don't like that, I can write that as 2.7 minus 5.2. Okay, and the thing is I would always, if you have a method that works, go ahead and use your method. You can change every single problem to addition. If that's what you prefer to do, it doesn't really matter. Okay, so you have 2.7 plus -5.2, and that's going to be -2.5. Okay, the sign of your answer is going to be the same as the sign of the larger number. All right, so what I mean by that is this: when I look at this is really plus plus, right? Subtracting a negative is adding a positive. So you have 18 plus 4. Well, clearly that's just 22. All right. You have -3 minus -5. Change that to plus plus. So you have -3 plus 5. So you have -3 and 5. The bigger number there is 5. The 5 is positive. Therefore, your answer better be positive. Okay. Better be positive. Part D here, plus plus. So you have -7.3 plus 6.4 plus 10.8. And then, at that point, having a calculator would be handy. You should be able to do that without a calculator. Clearly, I have it on your notes. No calculators. Okay. So you could do this one a few different ways. Since you're adding, you can add in any order you want. So I would add these two first. So I have -7.3 plus 6.4 and 10.8 makes 17.2. So I have -7.3 plus 17.2. My answer's got to be positive. And then when I subtract them, I get positive 9.9. Okay, and there are plenty different rules that you can memorize if you want. Okay, and we'll talk more about those in class. But I just want to kind of, again, this should be a refresher. Just want to kind of get your feet wet and make sure you guys kind of know what we're going to look at. All right, as we kind of go through this, again, if I'm going too fast for you, just go ahead and slow down, and you can pause, rewind, replay, whatever you want to do with the video. Okay. Example 4 says evaluate the expression when x is 2.5 and y is negative 3.4, just like what we did last chapter, right? So 2.5 goes in for x, negative 3.4 in for y, and then I just simplify. All right. So 2.5 minus, or I should say plus a negative 3.4 is negative 0.9 minus 9. So it's just going to be negative 9.9. All right. I'll do part B here with you, and then part C is going to be something that you can take a look at on your own. So x is 2.5 minus y is negative 3.4 minus 5.1. Parentheses first. So you have 2.5 minus parentheses negative 8.5. Just combine those guys. Plus plus. That's just going to be 11. Okay. So sometimes it'll work out nicely for you like that. Other times you're just going to have to kind of keep a decimal in there and live with it. Okay. And finally, as we get to the end of these notes, it says let A and B be negative numbers. Tell whether the value of the expression is positive or negative. Explain your reasoning. Guys, when in doubt, just pick two numbers and plug them in. Negative 1 and negative 2. Okay, so if we do this, the absolute value of negative 1 plus negative 2, right? Okay, the absolute value of negative 3 is positive 3. Okay, so clearly the absolute value of adding two negative numbers will be positive. Okay, we knew that though. This has to be positive because it's an absolute value. All right, it's the absolute value. When I look at part B, if they're both negative, well then you have the opposite of negative 1 minus the opposite of 2. So really what you have is these two negatives cancel to become positive, and these two do as well. All right, and that will always happen as long as A and B are negative. All right, so that will always be positive as well. Why? Because this negative sign and this negative sign will change A and B to be positive. Okay, because we'll look at the opposite of A and B. Part C, okay, if A and B are both negative, well, the absolute values will be positive, but you'll notice the absolute values are, the negative sign is out in front of the absolute value, so what you have is the opposite of the absolute value of negative 2 minus the absolute value of negative 1. Okay, well, you don't change this right now and say, okay, so plus plus. No, it doesn't work that way. All right, take the absolute value first and then apply that negative sign. Okay, so the absolute value of negative 2 is positive 2, so you have the opposite of 2 minus 1. Okay, negative 2 minus 1 is negative 3. Okay, so this guy is going to be negative. Why? Because the negative signs are in front of the absolute values, so it will always make your expression negative. And finally, D is going to be negative. Why? Well, anytime you add two negative numbers, you will always stay negative. All right, so again, the idea and the hope is A, that you are already familiar with most of this material, but B, that if you're not crazy familiar, this is a good refresher and hopefully provides you a decent foundation heading into class tomorrow, where we'll take more questions and answer any questions that you'll have.